Hello guys, I'm back on again with another video on GLR125. This time is the charging system. So in this video what I'm about to show you how to diagnose the battery, how to diagnose the stator or the alternator, whatever you call it, and we go through a little bit of charging system and I'll show you what the problem is and how to fix it. For doing the checking the alternator, what you need is a multimeter. So the first thing you're checking for is the battery, and as you can see the battery got 12.87. so you need to charge up the battery first and leave it on the bike for some time, measure the volts, what is the output on the battery, and leave it and come back within few hours time or maybe next day and make sure you still got the same value, pretty much same. So it basically indicating that all the wires is in good order and there's nothing short. So if the voltage dropped within few hours time, the first thing you want to do, take off the battery, leave it aside, measure the voltage again and come back after a few hours time, check the voltage again. If the voltage dropped furthermore, it means the battery is not in good condition and the battery either need to be replaced, or if it's a lead acid battery you might want to change the acid inside to see if it works. But if the voltage didn't drop while the battery is out of the bike, it means but the battery is okay. So if you return the battery on the bike and connect the wires again and the voltage drop, it means there is a short on the circuit. So as I turn on the ignition switch, the voltage will drop a little bit, and as I measure now is about 12.16 or 17 volt, and basically the lights and other electric components draw a little bit of current from the battery, but as soon as I crank the engine the voltage should come back over 12.5 or between 12.5 to 13 something, whatever, and it depends to the bike, and it's all the bikes are not same. And let's try to place this here. So as you see, the voltage was very low. The output, the alternator doesn't put so much charge on the battery. It should increase to 12 point, it should go all the way to 14, 13 half, up to 15 even. So the other thing you want to check for is the resistance. What I did here, just took off the alternator socket from the connection point, and what we're going to check for is the resistance between each winding, and it should give us the same reading. If there is a big difference between the reading of the resistance, it means we got a problem here. Apparently one of the winding is cut. So basically you need to check the reading between these two and these two. So you need to compare each point for first these two we got reading of 1 ohm. For these two up and the left one we don't have any resistivity. It means either is disconnected or is shortened at some point. And also for this 2 point is pretty much same. It doesn't read. So this is basically how you're supposed to check for the resistance of the ohm. And the other thing also you can check, start the engine again and see how much volts it puts out from each point of this. So I start the engine again. I get 1 millivolt. So it was completely clear that the alternator doesn't work properly. The voltage has to rise, get some reading in volts, but the reading I had, it was millivolts, so less than 1 volt basically, which is not right. And the resistance between the winding is different, so we don't check when you're checking the resistivity. So basically you're comparing the resistivity of each point to others. So basically when you connect the multimeter and you measure the resistance between these two, it should be same as these two or these two, because the number of the winding is same. So if you don't have a reading, it means either the wire is cut, or so there is a disconnection between the joint, or the connection is very poor. And also the other thing you may want to check for is your rectifier. So okay, now what I have here is the stator from the same motorcycle. This is the original one that I took off like a while ago, and as you can see, some of the winding is roasted. So what I'm gonna do now, I'm gonna basically, I brought my notebook here, I'm gonna undo it. So I'm gonna open up the windings and remove the copper wires, and then also draw to see which wire goes where, and also after removing put a new one on and see whether it works. So let's get started. If you got something from this video, don't forget to give me a like, and if you are new to the channel, subscribe for more. Right, what I did here is basically all the windings, they closed in the same direction. So if you face the stator, the clockwise direction it's get unwinded, and anti-clockwise get winded. So what I'm gonna do now, and each coil has 32 turns of the winding. So what I'm gonna do, I'm gonna wind up with the same wire, but this wire has a little bit of more thickness in it, within 1/10 of a mil more, but it should be okay. So let's wind it up. So this is my first time that I'm doing such a thing, so if I don't get it perfect, that's alright. Right, so I wind up most of the cores, and the way it goes basically is like a tree winding, and it goes one, you winding one, and you leave two empty, and you go for the third one. So and continue. So it's about like a 6 cores for each winding, and basically all the winding is the same direction. It doesn't matter as what direction you wind them up, because all at the same direction, clockwise or anti-clockwise, is gonna be same. And the tree end, this is a Y configuration, so the three end of the wires goes to the alternator, and the other three ends attached to each other. And the other thing is this wire to wind up this stator is quite thick and really give me a hard time, so I did it more. So it would be wise, if you want to do such a thing, to just go with the same dimension, same diameter wire, because the 1mm is the standard one, and I went for the 1.15 or 1.20. It's a little bit thicker. Alright, now one of the ends, I joined them together, and with the amrit paper or sandpaper just scratch the color off, and what I'm gonna do is solder it. So what we need to check for after the winding, first of all, I'm gonna check for the resistance. They should pretty much put same amount of resistance, so we check each wire to see what is the difference. So we got literally 300 milliohms, And if I go to the next one, same here, 300 milliohms here. And if I check it with this one, and we got the same amount here. And also we're going to check the resistance of the wires to the body to see if we made any short or not. So you can also check for continuity. So as you can see, it beeps, it beeps, it beeps. So it's connected. And now we're going to check to the body, which is isolated. So it means so far so good. So basically now what I'm gonna do, I need to open the other stator from the bike and put this on and see how it works. So I opened the stator, and there is the connection point at one of the end is disconnected, so that's it. But the winding seems to be okay. But what I'm trying to do now, I'm gonna put my one, to wind it up, so see if it works. Right, so the wire is changed. We add a little bit of extended the wires so it reached the socket, and I'm gonna place it on and see if it works. Also, I'm going to use the torque wrench, and it's going to be 14 millimeter, but I start from 13 and see. Right, now the stator is on, new winding, and let's check the voltage on the battery. 12.8 volts. Switch on, it draws a little bit of current, it's 12.3. Now let's start the engine and see. And as you can see, on the idle is about 12.5, and if I rev it up, it goes all the way to 14. Yeah, that's it. Thanks for watching.